Welcome. We are happy to see that you have joined. Eager to learn about Kairntech, about what we do, who we are. This webinar will be animated by myself. My name is Stefan Geisler, and by my colleague Vincent. And just to give you a bit of background, Vincent and I are several hundred kilometers apart. I'm calling in from Heidelberg today, and Vincent is located in Grenoble in the French Alps. And we are about to introduce you to the way we are working. So let's get started. First, maybe introducing you with a few words about who we are, where we come from. Kairntech is a software company that is pretty young. So we founded the company in December 2018, so not even a year ago. And we are a team of 10 partners located in France, in Grenoble and Paris. And as mentioned on the German side, in Heidelberg. And the team, although the company is pretty young, has been around for quite some time on precisely that field, analyzing essentially natural language in the form of natural language documents. And we have represented in our team the various competencies that you need in order to get such a project going in terms of software engineering, machine learning, but also in the more formal issues like sales and management and finance. Here you see a photo of part of the team, and in the middle you see the structure that gives us our name. That structure of stones stacked on top of each other that you often see in the mountains is a cairn. And we thought that this is a good metaphor, not only because a lot of people in our team come from Grenoble, which is squarely in the French Alps, but also because that structure provides guidance to trackers and people who are walking in the mountains. And in the same way, we provide guidance in the sometimes complex field about how to best apply NLP methods, natural language approaches for today's business questions. So we are like the cairn that guides you through this task. And we think that we can be good guides for that because we have been around for many, many years on this topic. People in our team have more than 15 years of experience in various contexts, like at Xerox, at IBM, at Themis. And although the company is pretty young, components that come from our team are in the open source arena already today in production in locations like the CERN, the NASA, or the EPO, and they form the basis of much of what we do. So our profile is, we come in, for instance, in the creation of document sets. As you may have heard and seen and experienced, a lot of the exciting new approaches in NLP require extensive data sets, and not always it is evident where they come from. So we come in assisting our clients in creating these data sets, creating the training corpora that many of the approaches today need in an easy and efficient way, and essentially in a way that allows domain experts to do these tasks, not only data scientists. So you will see that in the upcoming demo. Once these document sets have been created using our application, for instance, we allow to build document analysis services from these corpora. So we build the models and link them to, if it exists, to the knowledge graphs in the organizations, and all that in an industrial setting. So allowing people to do heavy-duty tasks using these newly created models to perform a specific NLP requirement. We are essentially a software company. So at the core of what we do, at the bottom of what we do here in this slide, is a software product, which we call the Sherpa, that you will see in a minute. And on top of that, we are also set up and prepared and experienced to provide professional services to our clients, making use of that platform, customizing, integrating that into your own environment. various numbers of questions are required here. What kind of data, which kind of model do we want to create? How do we annotate our documents? So we provide the professional services in order to do that. And on top of that, in a general sense, we can come in order to provide guidance for NLP and AI project at large, which is the top part of that pyramid. So what do we address? As I think many of you will agree, NLP-powered solutions today can add value to many document analysis processes in today's enterprises. But there's a downside. Document analysis applications often need to be customized. You rarely can just get something off the shelf and apply it to your specific project. In most cases, NLP applications, NLP projects require customization to the respective domain, to the respective challenge. The good thing is that in order to do that, a lot of NLP components today are available in the corporate, in the proprietary sector, but also today in the open source sector. This has dramatically changed over the last 20 years when hardly anything was present, was acceptable, was existing, and people had often to go out and do things on their own. Today, a lot of these things exist in ready-made and good quality, sometimes even in the open source domain. But still, these require often extensive manual rule or lexicon coding. So even though these approaches, the algorithms exist, often you need to sit down again, creating resources on which they fly and can perform their work. Now, again, the good news is that, as you have certainly heard, especially in the last couple of years, a new approach in this arena called deep learning often delivers superior quality and does without the necessity of writing rules, so learning from data. And these approaches from the deep learning side have often beaten all the state-of-the-art quality measurements of previous approaches. So this is now the new de facto state-of-the-art in many applications. But again, this requires that in order to get this off the ground, to make this fly, it requires both extensive experience in programming and also the availability of the proper training data. You have certainly heard that deep learning approaches often fly only when fed large amounts of training data, which in projects, in many projects, is a problem. Where do I get this training data in order to apply these methods? And this is where we come in. With the Sherpa, allowing people to train and to apply machine learning algorithms without the necessity having to program. So we address end users. So we address this observation that what people sometimes think, oh, AI, isn't that where you need to sit down and code clever algorithms in order to get a project going? The reality is rather that coding is still a part of what needs to be done. Of course, you better know what you're doing, also in terms of combining and applying and optimizing the algorithms. But in reality, in the day-to-day work, the majority of the effort goes rather into on which data do I run my training applications, my training algorithms in order to get a model. So this is essentially a very, very important part of the effort to get AI and NLP systems off the ground today. Where do I get the data from? And we will address that in the coming minutes, taking a look at how we support this process with the Sherpa. This doesn't mean that algorithms are no longer important, although they are sometimes even a commodity today. So for instance, I'm putting into this slide here a table about different approaches in entity recognition that you can find in the open source arena today. And even the top scoring system in that list is available on GitHub. So you can download it and start playing with it. This top scoring system in that list here happens to be from Zalando Research, the FLAIR framework that fared best on a well-known evaluation corpus, the Connell NER corpus, with something like a little bit over 93%. And just for the record, so you know, as I mentioned, we not only implement the Sherpa and apply it into industrial settings, but we are also active in this open source community. And a comparable platform, which we call Delft, implemented by the Kairntech chief machine learning expert, is also available in the open source domain and matches exactly the same state-of-the-art top results on the same corpus, on this Connell corpus, attaining 93.09%, with even a few benefits like creating faster and smaller models. So this slide, just in order to underline that underneath the Sherpa, we employ technologies coming even from our team that are among the best approaches that currently you find in that field. We now take a closer look at how we have set up this application that I mentioned now, the Sherpa. And in order to do that, I'm going to hand over the word to my colleague Vincent.
Yeah. Do you hear me?
Yes, we hear you. So I stop sharing and you share your screen now, right?
Yeah.
Okay, so
please.
We are now with Vincent.
Okay, so I'm going to share my screen. So let me know if you see it.
Yes.
Yes.
Yes. Loud and clear and sharp.
Okay, so perfect. So hello everyone. So regarding Sherpa that Stefan has already introduced, this platform relies basically on two stacks. And I will first present the first stack, which is an annotation environment, which allows domain experts, subject matter experts, to import raw text document set, could be pre-annotated corpora as well. So it's important to mention, if you have already a system which annotates content, we can import this document in the platform. And then this environment allows you to search, to filters document, to annotate document or snippets, as I will show you. We leverage active learning approaches, meaning that we have integrated in the platform a suggestion engine that you see at the bottom that will learn on your annotation and will suggest you some candidates you will have to validate to speed up the creation of training data sets. And of course, as output of this environment, you can get your training data set and also some AI models or machine learning models that you would like to deploy into production. Okay, so I'm going to jump to the application. So I hope you see my screen. So that's the Sherpa web interface. So I'm going to log in. All right, and you see on the home page, you have a set of different projects on different topics. So you see here some project related to news that I will demonstrate shortly. Then here you have some case law. Below you have some medical reports. You have also some information regarding transportation here, Munich transports, on clinical trials, on question answer with Ubuntu. So that means that the platform is generic, and that means that we can create training data sets independently of the sector on the domain. Okay, so here I'm going to present you this project News EN. So it's a set of news articles, so namely 400 documents. Each document have been segmented into sentences. And we already have in this project more than 3,300 annotations. Okay, so let's open this this project, and I will open. Okay, so here on the right panel, you see all the different labels I have already created on this dataset, meaning that here the goal is to annotate on some people, on organization or media business, measurement, location, and so on. So that's all my different labels on which I want to create annotation. So now, if I filter all my document set on only the segments that I have already annotated, so it means it's really my data set, I can browse and access all my different segments that I have already annotated. So let's go through. You see here, it's a basic example, but with the different color, you can see the annotation with the different labels. Okay. So I can go through and I can go to the last segment here. And I can open the whole document, and you see here that I've got a news article, plenty of annotations. All right. Now I've got this dashboard tab here, which summarize the training data set that I have currently in my system. So here, the first image is the distribution of my corpus on the different dates. So it's just for your information. So it means that I've got 400 documents. Then I have the distribution of my label on my data set. So I've got more than 3,000 annotation distributed in all these different labels. And I see here how it is redistributed, and I can see if I've got, for instance, a low number, a small number of events in my data set. And on the right side here, it's a projection of all my annotation, my segments, on the dates. So it allows me, or it could be another type of metadata. Here, in that case, it's date. But this might be very useful if we are missing, if annotation are missing on some dates or some topics and so on. So it's a way to control the right distribution of my training data set so as to make it consistent. And here, I've got my current model with the quality over time, because my system is every minute updated, and here you see the evolution of my model. So don't focus on the quality here, because it's a very small corpus of document. And definitely, if I want to improve the quality system, I will have to add new annotation or use other algorithm. Here, it's a very standard one with CRF suite, but the goal would be to test, to experiment with a different algorithm. So now imagine that I want simply to add some annotation. So how can I do? Very simple. Here I can select a segment that have not been annotated yet. And here, if I click on organization, I can add some new organization name. Okay, it's simply as that. Okay. So this task, of course, if I do it manually, it can be very painful and it will take a lot of time. So what we have implemented in the platform is this suggestion engine. So I can access to the suggestion time, and here I've got a different view where the system proposed me some candidates I have to validate. Okay, so here, for instance, let's say that this is a correct candidate, so I validate it, and here it's a period, so I validate. So then once I have validated these two propositions, I validate my segment so as to enrich my training data set. Okay, so here on this proposition, it's wrong, it's not a person. And so I have to remove this proposition, and this one could be good, so I validate. And you see that for each segment, on top of the list, we propose the segment with the less confidence, with the lower confidence, so as to help the machine to understand and to improve quickly the model. Okay. So now I can work on this proposition to improve my system, of course. But what I would like to show you is that imagine that I want to extend my model with a new label. How can I do that? So imagine here, I want to add a new label, title, okay? So I define this new label like that, very simple. And then I come back in the Explore view. I activate, you see here the title has been selected. And then I will use the search engine so as to retrieve, to find out some, some relevant segment in my current data set. And then, so I will use minister, saying, okay, probably I can have some title with these keywords. And then I want to start annotating. So here I've got exactly what I'm looking for. So I annotate this title here. Okay. So I can, create some annotation here, some new annotation. And at this time, behind the scene, my model is currently updating with this new information. And then, so I can keep creating some example. I can go to the next page, for instance, and select another candidate. All right. And then I can go back to the suggestion engine. And if I'm lucky, I can find my new candidates. So I have my colleague helping me creating some new annotations, because we need at least maybe 10 or 20 new annotation. So we will wait a little bit to see if we can have a new model. So since it's an online demo and we want to be fast, I ask help to enrich with new candidates.
That is maybe an important comment that we need to make here, that it's always a little bit delicate to find a good balance between a demo that is short enough in order to be that is possible to show it in such a context, and something that is telling. So you may have the comment that title seems like not the hardest of all imaginable tasks. We have picked that in order to make it realistic that we can show that in only a couple of minutes. So obviously the platform has shown that it can do more complex tasks like named entity recognition at large and beyond that. For the sake of brevity of this webinar here, we have chosen a simple example like extracting the titles.
Okay, so I've got, thanks Stefan. So I've got some candidates now. So you have, you see that this suggestion list, I'm able to filter on my labels. And here I've clicked on title, saying, okay, I want to focus on the title because I want to enrich my data set on this category. So here you see on the first segment where the confidence is not so high. So it means that the system is doubt a little bit on these candidates. So what do I have to do here? On the Prime Minister, I say, okay, that's great, but it's not perfect as a annotation. So I can correct it, saying Prime Minister, okay? And then I select, I validate the person. And finally, I validate my segment so as to enrich my training data set. And the next one you see here, the national, that's correct. The defense minister, that's correct. Vecni Gunul, I don't know this guy, but it seems to be a person, so I validate. Sunday, I validate. And gathering in Kiev, I validate. So then I validate and I enrich my data set in this way.
And maybe if I may, stressing that point again, so Vincent explained us that the list is sorted such that the not so sure candidates are on top. That may be confusing. You say, isn't the algorithm... But no, we deliberately focus on the less sure examples. It has been shown, and this tradition is called active learning, that by focusing on the less certain examples, you help the algorithms to get more quality faster than if you focus on the examples that are apparent at the start. So this is, we can't go into details about this approach now, but the fact that you see the less sure examples on top of the list is a deliberate action from our side, helping the algorithms to get quicker and more accurate more easily.
Thank you, Stefan. And you see here that I've just validated a few segments, and automatically the system, the model has been updated and suggests me a new list of candidates if I wish some new candidates. So it's automatically done behind the scene. All right. So now, as an example, we can, for instance, search a new document on Taliban. And I've opened this document, and then this is a document that I have that is not part of the training data set, meaning that the system has never seen this document. So what I would like to do is to test on this new document my model. So I can quickly go to the test page, copy paste the text, and annotate, and I've got the result of my annotation. Okay, so that means that imagine that you're happy with the quality of the system, with the dashboard, you can control everything, you have you have experimented some different algorithm, and now you're happy with the system, with the model. Then you can imagine to push this model on a production server. Okay, so I come back to my to the presentation. Here, it's a quick summary of what we've seen so far. So Sherpa, it's a web-based application. It's pretty intuitive, and it's dedicated to domain experts. It means I don't need to write code to build my own models. Okay. Then we leverage active learning to speed up the creation of training datasets. And it's a collaboration tool. We do not support just NER, name entity recognition. It was just an example of to illustrate the platform with very standard entities for the news. But of course, we do not stop at this stage. And lastly, we facilitate as much as possible deployment to production of our model. All right, now I would like to present you the second stack of the Sherpa platform. At the bottom left, in red here, it's what I've demonstrated so far, the annotation environment. So imagine I'm happy with my model. I want to push it on production. And here we have the second stack, which is basically an API, a REST API, but where we combine some machine learning models with knowledge base, knowledge graph, okay? And the most well-known knowledge base, it's Wikidata. So we have already integrated Wikidata in this platform, but of course, our goal is to take into account external knowledge graph, knowledge base from companies, and to combine everything to get the best system as possible to annotate content. So it's what I'm going to show you. On the last article, I processed in the platform, and the goal is to show you how we can leverage Wikidata beside a learning model. Okay, so let's go. It's just a screenshot to show you that it's not easy. Maybe Stefan, you want to comment this slide before the demo.
So what we emphasize here is that whenever you have large vocabularies, you have large knowledge resources, like for instance Wikipedia, Wikidata, or other non-trivial vocabularies, you will find ambiguities. Now, what is an ambiguity? Ambiguity means that you have entries in your vocabulary that can mean different things. We give you an example here with just the short acronym NHL. And it just so happens that depending on the context where you are in, NHL can mean different things. And we see it here by having on top a document coming from a medical background. And here NHL means it's a short form for the non-Hodgkin lymphoma. And fortunately enough, the system recognizes that, okay, we do have NHL, I know this acronym, and among the many different meanings that it can have, I pick the correct one and link this occurrence of NHL to background knowledge about the non-Hodgkin's lymphoma. Now, if the same string appears in a totally different document, in a different context, like the one that we have here at the bottom, which is about sports, here NHL means a different thing. It means it's a short form for the National Hockey League. So that is something that you see in many, many different vocabularies. And the question is, how do I make sure that if I apply this vocabulary to a set of documents, the algorithm always picks the correct one? And there are different approaches, and some of them mean that someone needs to sit down and, again, manually write rules. Oh, if I find a document that talks extensively about doctors and hospitals and cancer, it's probably the NHL, the non-Hodgkin's lymphoma. If, on the other hand, I find a document that talks about sports and Wayne Gretzky and I don't know what, it's probably the National Hockey League. And you can do that maybe for one or two easily, but if you do that for 100,000, it becomes unfeasible or cumbersome or extremely costly, which is why we stress that the annotation algorithm that we are going to show you in a minute, that Vincent is going to show you, does that automatically. So you do get an entity recognition and linking to the background information. So we see here that NHL is linked to the background information. Sometimes we have an image here, sometimes you have a little abstract. It's doing all that automatically without anyone having to write manual rules. This is what we wanted to show you, what we wanted to emphasize using.
Yeah. So thank you, Stefan. I think I'm afraid that we have some.
That's in domain find us. Okay. Yeah. Are you here? So
yeah.
It was interrupted.
I'm afraid that we have some issues.
Okay, so I made my point, and okay, so I hear you loud and clear, and I'm going to stop you now, letting you go into the live demonstration of this.
Okay. So thank you, Stefan. This is the live demonstration here. And what I do is that I take, you remember the article that I use in my the final test page. So here I do exactly the same thing, but we combine this machine learning with Wikidata. Okay, and then I submit this article, and you see that immediately I've got this article tagged. And here what you see is that this guy has been linked to the entry in Wikidata automatically, giving me all the information related this person. Of course, Iron is mentioned here, automatically linked to this Wikidata. But you remember in my model, I was able to extract people name, location, measurement, and so on, but not terms like Taliban, for instance, because that comes from Wikidata. So that means that leveraging Wikidata in real time here, we are able to extract some concepts, some terms like NHL, as Stefan mentioned previously, which allows you to add some new information on your text based on Wikidata content. So, and same thing for all these countries that are mentioned here. Everything is linked to Wikidata. So it's really a way to enrich deeply the content and to create automatically some link to give you some context regarding this article. All right, so now what I would like to strengthen a little bit, even if it's not part of our Kairntech Sherpa, it's what do we do all that stuff. So, you know, at the bottom left, we have this annotation environment. Here we have this REST API. The goal of all this system is twofold. The first one is to create some human augmented application. So it means it's not our goal today to create this application, but of course, this is to help companies, startup, or any organization to leverage, to use NLP technologies and to create application which augment employees, human, okay, like this one. Or the second possibility is to automate business processes. It means that we are able to automatically annotate content and automatically route some document to a category or perform some task automatically. So here, I just want to mention in one second the fact that we have some sample, some use case, and one of these is dedicated. It's in the finance industry, so it's not nothing about news, but it's in finance industry, meaning that we can address a lot of different markets. And here it's a solution, it's a business intelligence solution dedicated to the merger and acquisition market. And they use Kairntech Sherpa. And the goal, it's a kind of a recommendation engine. The goal is to identify automatically some potentially matching companies to help the financial guy to suggest some merge and acquisition. So I don't want to give more example because it's quite to dive into more details. This is the screenshot. I don't want to explain it, but here you understand that we can use NLP technology in a very, very different application like this one. Okay, so Stefan, maybe you want to conclude our webinar. It's 20 to 11. I think we have 1 minute to conclude, and then we can get some question on the chat channel. So if you already have some question, we're happy to answer them. So Stefan?
So let's briefly wrap up. What we have sketched is a situation where at least raw data is abundant. There's so much around, but very little of it is labeled and useful for your next project. So the question is how to address the demand to get labeled corpora. We have seen that in what Vincent has shown us. Also models, there are so many models these days around. There are model zoos, many of these are public, that you might be able to employ and try out on your specific project. But most of the time you will find out that they do just not precisely what you need in order to solve your task. So you need to take these models, refine them, or start them from scratch on your data. Sherpa again supports you in doing so. And also there are so many different algorithms, and often in projects, you don't have the time to dive into that and experiment and integrate all of them on your own. We showed you the Sherpa as an environment that supports you in doing that, wrapped in an easy to understand GUI such that it can be performed by domain experts. And on these tasks, we are there to support you. And this concludes the message that we want to convey. And we can now take a look at eventual questions that you may have that you could ask in the chat section of the webinar application. So we are going to take a look.
Yeah, so do
there
you see
are
my screen?
any...
So there is a first question. You showed more than 3,000 annotation in one example. How long did it take to get that results? Weeks, months? Okay, so here what we've done in this demo is that we used pre-annotated corpora. So it was very, very quick, of course. The goal with the platform is to then curate as much as possible this result, because it's very, very important to clean the data and to get the perfect data set. So it's key. So the first thing is that if by any chance you have some pre-annotated corpora, it's very interesting for us, because for everybody, for you, of course, with the platform, because you are able to import directly in the platform this information. And then you have the graphical user interface to improve, to enrich, to extend, as I demonstrated. At the opposite, if you don't have any pre-annotated corpora, it means that you have to create first your labels, and then you have to rely on the suggestion engine. And what we see is that we can create, let's say that in 15 minutes or 20 minutes, you can create 500 annotations. It's not a problem. It's not a big issue. So the goal is really to save time, to speed up this process with this platform, definitely.
Mm-hmm. So there are two more questions that came in. One is about, did we also train customer care messages? So as Vincent has shown us in the beginning, in his system, there's already a wide variety of different scenarios. There are support questions on Ubuntu, and there are news and medical reports. So right now, we have not yet applied that on customer care messages, except that maybe we can consider this Ubuntu forum that we have analyzed as an example for that. We are pretty confident that what we have shown here and what we have implemented is pretty domain agnostic. So our assumption is that it applies also to the corpus that you have in mind, but we haven't done it yet, except for that, for the Ubuntu care message. Which connectors exist to put text into the Sherpa? So right now we have defined a couple of import formats. Obviously, raw text can be imported, so text that does not yet know about any of its annotations. But we have also defined a specific JSON format in case where you already do know some of the annotations inside the text. Then the necessity would come up to transform your data into this easy JSON format and import it for that. So these are two of the scenarios that we currently have implemented. And as you can imagine, this will never end. So we are in the process of integrating yet another source. So we are right now, for instance, in the process of integrating ourselves into a project on the European level that has a corpus database inside and connecting to that, and so on and so forth. So in terms of connectors, there will never be enough. So I will jump to the next question. Do you have experience with contract data? So for instance, termination clause and notice period. Here, the same statement applies as before. So we do not have a ready-made project yet. We have experimented with contracts that we find in the public domain. So for instance, we have downloaded a large corpus of contracts from the SEC in the United States and applied our methods there precisely on questions like, you have a lengthy document, and I only want to find out the date that the contract was signed, or maybe the partners that have signed the contract. And we see that we can apply the Sherpa on this thing as well. So in terms of extracting specific entities for a new domain, like from free text and contracts, we are happy to see that the Sherpa behaves gracefully and productively here as well. Jumping to the next question, the normalization of entities to Wikidata is already part of the entity fishing suite. Yes, it is. Have you experienced how this approach performs on mapping to vocabularies in the biological or biomedical domain? For instance, mesh. So mesh is a part of Wikidata. So whatever concept you see in mesh is also in Wikidata. And as mentioned, we see that with the entity fishing approach, we are able to disambiguate. So if that was the example that I showed you, the non-Hodgkin's lymphoma, I'm not 100% sure, but I bet that it is a mesh concept. It is represented not only in Wikidata, but also in mesh. And we were able to extract that with the proper meaning from a biomedical text and with another meaning from a non-biological text. So we disambiguate. And honestly, this approach is in place in scientific context. So we mentioned that it is doing entity extraction in some projects where these approaches are already in production today. So we are we are confident that whatever application you have in mind, it might make sense to experiment whether this hope bears out and delivers also quality results on that one. Jumping to the next question, if I upload a pre-annotated corpora which has 20 labels, can I drop, for example, 10 labels, leaving only those that are relevant? If yes, will the model be retrained on the 10 label as soon as it's done? So here I might have to pass the word to Vincent. I think.
So the answer is yes, but there is a but. We don't have the button in the user interface yet, but this is something that we will create in the UI very shortly, because we have everything to do that, but the button is missing. Yeah, but the answer is yes.
Yeah. So as you guess from this answer, also the GUI that we showed you, the Sherpa GUI, is under constant development. We see right now that it's answering to a lot of demands in a productive and easy to use way, but there will be, this is the fate of any GUI, there will be new questions. Can I also do this and that? And this will often be turned into a question to our GUI developers, saying, can the next release also foresee a button here and there to allow this and that user in this and that circumstance to do this and that action? So right now, we know how to, obviously, to drop an entire entity type, as the question has demanded, but the GUI today doesn't allow it to do that by just clicking on a button. So it will come
shortly. Yeah, of course.
So 2 more contributions in the chat, but these are essentially saying thank you to having answered the question. And beyond that, we are confident that, or we hope that you have appreciated the session. And if there are any questions around the Sherpa as it is today, or whether it can in the future also address a scenario that you have in mind, but that we haven't mentioned, feel free to contact us, and we will come back to you, and we will try to answer your questions also after this session here. Otherwise, thanks again for joining us today, and we keep in touch, and have a good rest of the day.
Thank you very much. Goodbye.